Welcome back everyone to the eCoreAcademy e-learning platform. My name is AJay back with yet another Algebra 1 video for you all, and today's lesson topic is all about linear equations and specifically writing in slope-intercept form. This video was helped in being prepared and created by Tanya Patel, the other teacher here at Algebra 1, as I will also be helping in teaching this to you all, presenting this to you, and also inputting my speaking points to help guide you through this entire lesson and this topic, and help you understand the concepts of slope-intercept form, how to use it with your linear equations, and of course your graphs overall, and also how to solve linear equations properties with slope-intercept form as well. So before you jump into today's lesson, please make sure to do 3 things. Please make sure to smash that subscribe button, hit that like button, and turn on post notifications. Also feel free to leave a comment down below and share using YouTube. Those 2 are optional, but they really do help us out. So thank you for doing all of those things, and let's jump right into the video. So, as you can see up on the screen, this is exactly what your slope-intercept form is. It's a type of linear equation that expresses a line. We know that a linear equation always expresses a line graphically, and there's always 3 different equations that can represent them. So, when it comes to linear equations, you have standard form, point-slope form, and of course, which I think is the most common one, is your slope-intercept form. So, your slope-intercept form is conveyed in the manner of y equals mx plus b. As you can see, there's probably 2 things that you know immediately, your y and your x coordinates. Those are your variables that you're going to plug in with your coordinates all along your line. Now, there's 2 other counterparts that you might not necessarily be familiar with. There's m and there's also b. So mx is the entire grouping there, m multiplied by your x coordinate. So the first thing that we're going to do is we're going to start by finding the m, which in other terms is your slope. So the slope formula, how exactly would you find m? We know that m represents your slope, and slope is merely the change in your y over the change in your x values on a line. So if you look at a line, look at a linear graph, essentially what you're going to be doing is you're calculating the rise over the run. The rise is going to represent your y values, how much your y increases every time you're going over a certain distance. So it's your rise over your run. Another way to convey that is y2 minus y1 over x2 minus x1. So you can use any 2 given coordinates of the graph to find the slope value. You could take 2 coordinates, they both have an x and y cohesively, correlatively. So in this case, we have y1 and x1 would be 1 coordinate pair, and then of course y2 and x2 would be another coordinate pair. All you're doing is you're subtracting the value of the y's and then the values of the x's, and then you're dividing that rise over the run, the difference in y over the difference in x, and you're getting your slope. All your slope really represents is the steepness of your graph. Remember, if we review those basic Algebra 1 topics, the larger your slope is, the steeper it's going to be, the closer your slope is to 0, or overall, the closer your slope is to 0, essentially the shallower it's going to be. It's going to be closer, hugging your x-axis. So in that same manner, slope does have a massive impact in creating unique linear equations and also characterizing the slope-intercept form. All right, so now let's move into some examples, some simple examples. So what we're going to do is we're going to look at 2 points on a line, a basic linear graph, 6, 3 and -5, -3. They both exist on the same line. And all we're going to do is discover what m is, m being your slope of the equation. So we know that slope, of course, is your change in your y over change in x. And a common way to represent that through mathematical notation is delta y over delta x. Delta merely means the change in y, and then of course delta x means the change in x. So that's going to equal our m. So what exactly is the change in y? Well, that's going to be your y2 minus your y1 over x2 minus x1. We know that y1 and x1 are in the first coordinate pair. That subscript of 1 says the first coordinate pair, and then y2 and x are in the second coordinate pair. So let's take a look at the first coordinate pair, 6, 3. So we know that x1 is going to be 6, and we know that y1 is going to be 3. And then on the, of course, for the second coordinate pair, we have -5, -3. Since it's the second coordinate pair, -5 is y2, was x2, and the -3 is your y2. So let's plug those values in. We're going to put -3, this in parentheses, -3 minus 3 over -5 minus 6. So in this manner, we have all of our, we have everything in the proper position, and we're merely calculating the difference a change in y over the change in x. So negative 3 minus 3, that's negative 3 plus negative 3, that's going to be negative 6. And then of course negative 5 minus 6, that's negative 5 plus negative 6, and that's negative 11. Therefore your slope is going to be 6/11. So m, in this case, will equal 6/11. And when you plug that into your y equals mx plus b equation, you'd substitute 6/11 for that m there. It would be 6/11 x plus b. All right, now let's move on to example 2. So in example 2, we're going to also do the same thing, but just change up the numbers a bit just to get a hang of it. So this is example 2. We're going to find the slope between points 6, negative 3, and of course negative 5, negative 3. So we know our slope equation. We're going to merely identify what these variables are in terms of y2, x2, so on and so forth. So we know that 6 right here is going to be your x1. Negative 5 here is going to be x2. Negative 3 is going to be y1. And of course, negative 3 here is also going to be y2. So now let's calculate this. Let's plug this into our equation. Difference of y's. We're going to put negative 3 in front. Always y2 minus y1, and then x2 minus x1. So negative 3 minus your negative 3 here. That's going to be all over your negative 5 minus your 6. All right, so now that we've done that, we can really simplify. Negative 3 minus negative 3 is going to be 0. That's over negative 5 minus 6. That's going to be negative 11. So now here's a very interesting topic here. Many people oftentimes get confused. Wait, when you divide a number into 0, doesn't that technically make it like undefined or something? It cannot be represented. Well, in this case, you can always divide into 0. However, you cannot divide 0 into any number. Meaning, if this were negative 11 over 0, this would be undefined, so it would be a vertical line. But in this case, since it does have the property in which negative 11 is divided into 0, it's merely going to equal 0. So in this case, it would be the opposite. It would be a horizontal line in this case. So what we're going to do is put y equals 0x plus b. So your y-intercept is merely just going to equal your y value every single time you alter it or change it in this case. So therefore, it's actually just going to be essentially your horizontal line going laterally this way. It's not undefined because it's not, so it's 0 being divided into a number. So m would equal 0. All right, moving on to example 3. Let's find the slope between the points negative 5, 4 and negative 5, negative 3. So of course, just the regular routine. Negative 5 is your x1. Negative 5 is also your x2 here. This is your y1, and this is your y2. We're going to plug those into our equation. Y2 minus y1, so that's negative 3 minus 4. We're going to divide that by x2 minus your x1, so that's going to be negative 5 minus negative 5. When we simplify that, we get that negative 3 minus 4 is going to be negative 7. And then, of course, that is divided entirely by negative 5, essentially plus 5, so that's 0. So in this case, this is a very interesting situation here. This is actually going to be the opposite of what I showed you previously. So previously, we were dividing a number into 0, meaning 0 is dividing by a number, by negative 11. But in this case, we're going to be dividing negative 7 by 0. And in this case, you can never divide by 0. It's always an undefined value. You cannot divide something into nothing, essentially. So negative 7 divided by 0, that's going to be something we call undefined. Anything divided by 0 is always undefined. And in this case, since the slope is undefined, this is always going to be a vertical line going up and down. Alright, so now let's move on to the other counterpart that we haven't covered. So now that we have a good grasp of what m is, our slope, let's calculate what b is, our y-intercept. So for the y-intercept, there isn't any smooth formula that you can actually calculate with as stated on the screen. You just have to plug the m into the equation and all of the other counterparts, meaning you plug in your y and x, any coordinate pair on the line, you can plug those values in, and you'd also need to calculate your slope. So once you plug in your m, then your x and your y as coordinate pairs, then you can always calculate for b, because it's just an equation. So let's do exactly that. So given 2 points, 4, 6 and negative 12, negative 2, let's find the equation of the line that intersects these 2 points. So we're given 4, 6 and negative 12, negative 2. We know the first thing that we need to do is always find your m, your slope. So let's do that. We know that our 6 and our negative 2 are our y's, and our 4 and negative 12 are our x's. So it's going to be negative 2 minus 6 over negative 12 minus 4. We simplify, we get that negative 2 minus 6 is going to be negative 8. Over negative 12 minus 4 is negative 16. That simplifies to 1/2. So m equals 1/2. So now that we have m here, we're going to take one of these coordinate pairs and plug it back into our equation along with n. So we're going to take 4, 6 just because it's smaller numbers and they're not negative, so it's a lot easier to work with. So we're going to plug in 6 for y, plug in our m, 1/2, so our original equation being y equals mx plus b. We're plugging in 6 for our y value here. We're plugging in 1/2 for our m, our slope. And then, of course, our x is going to be our 4 right here, so we're going to multiply that by 4. And b is exactly what we're solving for, our y-intercept, where the line intercepts the y-axis. Right there. So we're going to calculate this, simplify. So 1/2 times 4 is going to be 2. So 6 equals 2 plus b. And if we subtract from both sides, we get that b is equal to 4. Therefore, our final equation is going to be y equals mx plus, a format of y equals mx plus b. It's going to be y equals 1/2 x plus 4. As you can see, our b is 4. It's our y-intercept. Our m is 1/2. It's our slope. And that's all you need. Y and x are always interchangeable with other numbers in your line as coordinate pairs. So those stay as is as your variables. So that's our final equation. All right, so let's find the equation for our first 3 examples. These are just more problem examples, so please stay tuned. So, example 1, let's find the equation of the line that intersects these 2 points, 6, 3 and negative 5, negative 3. And we're also given that the m, the slope, is going to be 6/11. So let's plug those values into our equation. So we get that, so far we have our m, so we can plug that into our equation. We get that y equals 6/11 plus b. So now the only thing that we're missing is our b. But since we're also given coordinate pairs on the actual line, let's choose one of these coordinate pairs. Let's take 6, 3, for example. Let's plug this back into this equation, and then we can merely solve for what b, or y-intercept is. Just add it in the x. Okay, so let's put in our 3 equals 6/11 times 6 plus b. Now when we do that, we get that 3 equals 36/11 plus b. We know that 11 times 3 is 33, so it's essentially 11 times 3 is 33. So that we know that it's going to be 3 and 3/11 in this case. So we're just going to multiply that, subtract that value out. So 3 equals 3 and 3/11 plus b. We're going to subtract that from both sides, and of course we get that negative 3/11 equals b, our y-intercept here. So we can plug that back into our equation. We get that y equals 6/11 x minus 3/11. All right, now moving on to example 2. Let's find the equation of the lines that intersects these 2 points, 6, negative 3 and negative 5, negative 3, with the slope being 0. So first, of course, we're going to calculate our original equation, what we have so far. So y equals 0x plus b. Of course, we're just solving for a y-intercept in this case, our only left remaining variable. So we'll start plugging in our coordinate pairs into this equation. So we'll take 6, negative 3 as our first coordinate pair, and we'll start plugging that back into our equation. All right, so negative 3 equals 0 times 6 plus b. 0 times 6 is 0, so negative 3 is going to equal b. And our final equation is going to be y equals our 0x plus our negative 3 minus 3. That's our final equation. And for our very last example, we're going to find the equation just like we did before. We have 2 points, negative 5, 4, and negative 5, negative 3. And we have our slope that is undefined. So when we develop this equation, we're going to plug in exactly what we know. So we know that y equals mx plus b. M is going to be undefined. So the only thing that we're really solving for is b. So in this case, let's start to plug in our answers, our typical equational answers. So we'll put in 4 for our y here, and we're going to plug in -5 for our x. But the tricky part here is, what do we plug in for undefined? Well, when you're plugging in for your undefined, essentially, what's going to happen is what's going to happen here is you can't plug in any value for an undefined slope. You can't plug in 0, because then that'll make your slope 4. I mean, your y-intercept 4. But in this case, all we need to do is figure out what the equation of the original line is. We know that when it comes to a vertical line, it's always defined by what part of the x-axis it intercepts. And as you can see here, we know that the slope's undefined, so it is a vertical line. And we know that -5, 4 and -3, they both have the same x values. So that means the equation of the line is going to be that y equals -5, essentially. Your x equals -5, essentially. So when x equals -5 here, when x equals -5, that means all values on that -5 line are always going to equal -5. So in this case, you cannot use the traditional methods. And also, because x equals -5, and since x doesn't equal 0, you're not going to have any y-intercepts. It's not going to intercept the y-axis. Therefore, your final equation would be that x equals -5 in an undefined term. Alright everyone, so that'll be it for today's video. This is the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below, turn on post notifications, leave a comment down below, and share the video through YouTube. Check out our website at www.eCoreAcademy.org. We have really cool and interesting note sheets, quizzes, and worksheets organized into a full course study for you to take a full online course for free along with our videos. So also, feel free to email us at eCoreAcademy@gmail.com if you have any questions about that, or just general questions if you want to reach out. And check out all of our socials, Facebook, Twitter, Instagram, TikTok, and Pinterest, all at eCoreAcademy, and see what kind of interesting content we have there, aside from our YouTube channel, just some fun, interesting content. Alright everyone, so that'll be it for today's video. I hope you guys enjoyed. It's been the eCoreAcademy e-learning platform, and I hope you guys, saw this as a great review, if not a really nice learning lesson, and I'll see you guys in the next one. Peace.